Hey folks, in this video I want to introduce how hash functions and hash values are implemented in Java. Alright, so first thing is of course hash code. So we talked about this at the beginning of the course. I was like, oh, we'll come back to it later. Well, now is later. So this is what we've kind of been avoiding for a while. This is in Java a hash function. Now for Java they call it hash code. And it's the standard way basically to say, from a class, give me your hash code, right? Give me the hash value, right? That magic number that encodes your identity. Okay. Now, by default, Java has some sort of background implementation. This is one of the methods, right? That's kind of a default method, and it's coming from that object parent class that everybody has. It gives you a default. The default is just the address of the object, though, which is not such a good hash if you think about it. So if I have basically the address being the hash, what happens is that if I have something like different strings, well, they'll have different hash values, so that's okay, right? The address at least is some unique number of where it's stored in memory. But the problem is if I have two different objects, right, that I use the keyword new twice, and they both have the same data inside, right? I set them up the same way. Well, what happens is they have to live at different places in memory. Their hash code isn't going to be equal. So this implementation works sometimes, but not all the time. So for us, what we want to do in Java is whenever we're actually asked to implement a class with hash code, right, is implement it from scratch, right? So that it basically calculates the proper identity number, right, that is where the hash is supposed to be. All right, so what are the rules? So let's say we have a class like A. And this class, right, maybe I can create different objects from it. So I have O1, O2, O3. My kind of obligation here is going to first of all be that when I have a class and I implement hash code for it, all of the instances I create from it basically should be should have their own hash code, and that own hash code should be evenly distributed over all of the possible hash codes I could ever have. So our function in Java has this return type integer. Integers in Java are signed, right, so they can be positive or negative. And there's actually a symbol called maxint, right? So maxint is basically what is the largest number I can store, and it's basically dependent on how many bits did you allocate to this int, right? So if you have slightly different programming language or whatever, right, that has more bits or less bits in an int, then kind of the maximum number you can store, will differ. But in Java, right, basically I just use this symbol maxint to represent the largest possible integer I could ever have. So anyways, maxint, right, is some sort of value here, right? So it's like I have this interval over here, right, from negative max to max. And in that interval, right, my different objects that I create for my class, all of those should be, kind of randomly distributed or evenly distributed. I don't want to have them all cluster up, right? So I want something like that, okay? And that's kind of what Java is expecting. It's expecting that when you're producing a hash code value, you're producing something that basically spans the entire interval of the possible integers that are out there, because you want you want to use as much freedom as you want, right? That'll kind of reduce the chance that you ever have duplicates or collisions. So you want to kind of span it as well as you can. And then keep it well distributed. Okay. Other thing here, right, is that basically there's this relationship between hash code and equals. So equals is a method you guys have used in the past, and the purpose of it was basically to check two objects and see whether they are the same or not. And you implemented it and it was fine, and then you had to look a complaint in your ID saying, oh hey, why didn't you implement hash code? Hash code is also important, blah, 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 blah. Well, the reason for that is that there is this contract in Java which says the following. X equals Y if and only if, right? So that means that if the left side is true, the right side is true. If the right side is true, the left side is true, right? And the same thing for false. They have to be, match exactly. They're equal, right? If and only if their hash codes are also the same, okay? So obviously if you implement equals, but you're using that default implementation hash code which looks at the address, there's going to be a mismatch sometime, right? And that's going to break. So that's why your IDs complain. All right, so let's see. Right now, right, we're saying that in Java, we're basically computing a hash code, right? It could be some number from maxint to negative maxint to maxint. Here, though, we kind of had to note, though, that it's, it's maybe a large number, right? It may be a large number, it also may be a negative number. And when I say large, I'm actually talking about is in reference to that m value. So we said before that we were going to try to store things into an array of size m. Well, the problem is that if m is really small, like 10, there's still this chance that in Java the hash code function runs and I get something like 5,372,000, right, as my hash value. How do I fit that into that array of size 5? I can't, right? So I need to deal with that. I need to deal with the fact that my values can be too large and also that they can be negative. And so the way we deal with that is basically once we start talking about actually implementing a symbol table using a hash table approach, is by using this little bit of code here. So this is saying, okay, give me the hash code from Java, and it was with x7 FFF, and then modulo by m, right? So there's two steps in there. Some of the idea, right, is first of all to remove the sign, right? So this is actually going to mask out the sign. And then here is to, fit into the array. There we go. So it's a little bit more of a process here. So actually, let me go back and I'll actually expand the diagram we started drawing earlier. So we had, for example, we started with object. Object becomes basically a hash. And I'm going to label this a little bit different than I did before just to match the notation here. Hash code, right? So hash code takes an object to a hash, right? And this is, an integer here. Well, yeah, an integer. Could be very large, right? And then, right, we do this. We say we do a, well, I'll basically say we do, well, pretend let's say, yeah. Well, let me try again. Let's see if I can get a good ampersand. There we go. We do our ampersand and then also our modulus. We do those things and we get an index, which is also an integer, but it's now an appropriately sized integer, right? So this one goes up to n versus this one over here went up to max int. So this is how our process looks. This stuff over here on the right-hand side, or left-hand side, is basically like hashes in general, and the right-hand side is moving into the actually implementing a hash table, right? Actually implementing the data structure. So yeah, make sure you kind of understand the little flow there, right? We don't want to do our modules too early or anything. We have to do it just at the very end, right? We first start by having our object, getting a hash from it, right? And then once you have a valid hash, then we make it fit into our array, right? That'll be kind of our staggered steps here. So before we end this video, let's take a look at basically an actual method that implements hash code in Java. So that's what I have here. This is basically going to be a hash code for the transaction class. So, how does this magic number get built? We talked about some basic rules, right, for things like hashing an integer, a float, a string. We had some ideas there. How does that look in practice? Specifically for something that's a little bit more complicated, like transaction, which has different parts to it, right? Who was the transactor? What date did it take place? What was the value? How do we do that? Well, we have an example right here. So most of this, right, is basically just my class, and you can see by the ellipses there that I've excluded some of it. So I just threw away stuff that didn't really matter. But we have here what we want to concentrate on, which is basically our hash code function. So we have our hash code. Let's just take a look at it. I mean, there's text to read on the slide, but let's just take a look at what's going on here. So our goal, right, is to generate this unique number, which basically represents the identity of our object, right? So we're going to look at our state and try to compute something from that. So, all right, what's happening? So initially, we start with a hash variable, right? And that's the showing over here. And we set equal to some constant. And this really, I could pick anything. It's just a number, just something to start with. And then here, I'm going to start the process of kind of mixing that hash and then adding some knowledge from the kind of the state of the object. So here, what my first line is saying is, okay, I'm going to update hash. So it's going to be the old hash value times 35 plus the number that's the hash of the person, the who. The idea, right, somehow is that, if you already have, if you already have basically some sort of hash code available to you, right, some hash code function, just go ahead and call it, right? And so call it and then mix it in. So that's what we're doing here. Same thing happens again, right? Next line again, we're basically going and we're kind of mixing up hash, adding in the hash code of when, right? Mix, add, mix, add. And we just do that for all three, right? We do that for all three, and eventually at the end, right, we get this hash value here, which basically by this math here, that number, right, that we have for inside this hash value was calculated from the three other, hash codes of the stuff inside of it, right? So if I change any of the stuff inside of it, it's going to have a change in this hash value here that this function is computing, okay? So yeah, this is kind of the basic approach. Just as a quick addition here, if you maybe want to do something like so let's say you had for a second something like this. Let's say we had private int id equal 10, something like that, I don't know. The other way you could do this, right, instead of just having all hash codes there, is also having another line looks like hash 31 times hash plus ID, right? So it's like you don't always have to call the hash code function. If you're made up of complex pieces like a date, you should, right? But if you just have plain stuff inside you like an integer, you just add it in, right? That's kind of a simpler thing you could do if you had some other thing. All right. So yeah, this is kind of how we do it, right? So in general, right, there's two things. First of all, when calculating our hash code, it should be impacted by every single piece of data that my class has. Okay, that's kind of the general rule. And then the thing that kind of helps us get there, right, is doing that addition with multiplication and then reusing hash code, right, when it's already available for us. All right, so now you guys hopefully have a good sense of how Java uses hashing, right? So that basically the hash code interface and also how we kind of implement it here.